So, as we talked about in the previous circuit, you can have two different circuits. This particular circuit is called a half wave rectifier. And basically, the output of this circuit in response to a sine wave is going to look something like this, right? It passes the positive half of the signals and cuts off the negative part of the sine wave, and then it passes the positive, cuts off the negative, passes the positive, cuts off the negative. So that would be half wave rectification. A full wave rectifier, on the other hand, would give you have the positive part passed through, and the negative part is flipped so that it becomes positive. Then you have the positive part, then you have the negative part, positive part, negative part, and so on and so forth. So both sides of the signal are passed through, but they are all switched to the positive side. So that's how a full wave rectifier works. Now the question is, why are these rectifiers used and where are they used in? And the answer to that is basically, I think, apparent when you try to think of what is the mathematical operation that this full wave rectifier is doing. So half wave rectifier is kind of a full wave rectifier with some distortions built in, right? So what is the kind of operation that the half full wave rectifier does? So what is the operation that is being done? And one way of thinking about that is, you could say that VO in a full wave rectifier is equal to the absolute value of V in, right? So um, I think that's self-explanatory. So you take V in and you take the absolute value of VO, you basically discard the negative sign, and the output that you get is VO in a full wave rectifier. Now, where would you use that? I think one of the primary uses of rectification is in converting AC signals into DC signals. Okay, so the issue with AC signals is that it goes both positive and negative, right? So it's a signal like this. Now, if you take the average value of this particular signal, it is going to be zero, right? The average value of a sine wave is just zero. Now, if you want to convert this into a DC voltage, what do you mean? What do you want to do? What you want to do is you want to get a value which is, let's say, equivalent to the RMS value of this signal, right? So one way of doing that would be to rectify the signal, do this or this, and then take the average of the signal. And that gives you some equivalent of a DC. So that converts the AC voltages into DC voltages. Okay. So the use of rectifiers is in converting, let me write it here, AC signals into DC signals. Of course, right now we still have this changing signal, even though it's become one directional signal as DC signals are. We still don't have this as a constant signal, but you can make it constant by having a low pass filter, right? You can get the average by putting a capacitor at the output instead of a resistor. So the capacitor gets charged up to a particular DC value and maintains that charge.